Welcome back, and now we're going to be talking about the basic DLs that we know that we don't have to, at each time when given a question, have to first calculate it before applying it in the question. You can just know them and then keep, when they ask what's DL of, for example, cosinus x times sinus x, just put in DL of cosinus x in DL of sinus x. You don't have to start calculating the DL of cosinus x and over as nash to 0, sinus x over as nash to 0, and then you merge them. So that's why we call these ones the basic DL, just like basic integral, basic derivative. These ones we also have the basic development limit. We're going to start with exponential x. Exponential x is pretty straightforward. We have 1 plus x over 1 factorial. We are going to Lord root 4. Back at x equal to 0, Lord n equal to 4, n equal to 4. So we have 1 plus x over 1 factorial. We have plus x squared over 2 factorial, plus x raised to the power of 3 over 3 factorial, plus x raised to the power of 4 over 4 factorial, plus x raised to the power of 4 epsilon of x. So this is one of the basic integrals and basic DLs, I'm sorry. And we can use this exponential x to get cosinus x and sinus x. We do this just by alternating the signs from exponential. So if you know the DL of exponential x, you can actually get the DL for cosinus x and sinus x. It's pretty cool, right? And exponential x is actually easy to memorize. 1 plus x squared over 2 factorial plus x raised to the power of 3 over 3 factorial, and so on, up to x n raised to the power of n factorial. It's that straightforward. So I'm going to first look at the cosinus x part. So if we are getting the DL of cosinus x from exponential x, we look at the even part of it. The even part, that's starting from 1, then look at the even part. So I have 1, x, it's an odd one, there's x raised to the power of 2, x raised to the power of 3, it's odd, so I'll take x raised to the power of 4. Exactly. For cosinus x, you just take the even part from exponential x and place it in your cosinus x. That's one. Secondly, you alternate the signs. Where I see a plus, I'll start with the minus, then a plus, minus, plus, minus, plus. So you just keep alternating the signs and bringing out the even numbers from your exponential x, even part from your exponential x. In this case, we have 1, right? Then this is plus minus x squared over 2 factorial. Then the next one, which is x raised to the power of 4 over 4, becomes plus x raised to the power of 4 over 4 factorial. Yeah, you guessed right. The next one will be minus x raised to the power of 6 over 6 factorial. Then plus, minus, plus, alternating the signs while picking out the even part from your exponential x. So this will be x raised to the power of 4 exponential x. Pretty straightforward too. So 1, you take the even parts, and 2, you alternate the signs. Yeah. So for cosinus x is the opposite, contraire. I'll alternate the signs as well, and then I'm picking the odd numbers starting from x, because 1 has been taken, x squared over 2 has been taken. The ones that have not been taken, that's the ones we're going to put in sinus x. So it's like sinus x is taking the rest. Yeah. So we're going to start from x and keep alternating the sign just as we did with cosinus x. So we are taking this. If we had an x raised to the power of 5 over 5 factorial, we'll take that as well. So here we're going to have x over 1 factorial. Remember, we are alternating the signs as well, and we're taking the odd ones. So we have minus x raised to the power of 3 over 3 factorial. Let me just add 5 so you get to know what this is. And this will be plus x raised to the power of 5 exponential x. Oh, this, just do this. Well, yeah. So that's the way of getting your cosinus x and your sinus x from exponential x. And this is basic. Each time you're given, you just have to apply it directly without any stress. Yeah. So next, I'm going to give us another one which we've already seen from our previous video. It was one of our examples, and we're going to use that also to derive other DLs. But before that, we're going to try out the log ln of 1 plus x, which is also a DL. All these, please, you should make them your record book so it can be stuck. It took me a while. I actually had to write the entire table, place it on my wall, and sometimes before I go to bed I recite it. Yes, recite. I recite it until I felt I was okay, but still sometimes I still have to come back to actually help myself, because you know, no one's perfect. So you could also try that method, you know. It works for me, and hopefully maybe it will work for you. But if you have other ways in which you memorize, I'd really love to know, because I'm really exploring different options. Thank you. And so back to, yeah, so we have ln of 1 plus x, and ln of 1 plus x is basically x minus x squared over 2 factorial plus x cubed over 3 factorial minus x 4 over 4, sorry, no factorial. I got so excited. So ln of 1 plus x is just x minus x squared over 2 plus x raised to the power of 3 over 3 minus x raised to the power of 4 over 4, etc. You see, it's basically that. That's basically the DL of ln of 1 plus x. You keep alternating the signs, and in this case the difference is that you don't have any factorial and there is no 1, yeah, at the beginning. So we don't start with a constant, we go directly to x, and then we keep alternating the signs, and then no factorial. That's ln of 1 plus x, the DL. Pretty straightforward. So the next is the one I was talking about, like we already calculated in our last video how to get this, and we had 1 plus alpha x plus alpha minus 1 over 2 factorial x squared. Let me go to, that's plus x squared exponential x. We went to log order of 2, and this is another basic basic DL, and we can use this also to get, please don't forget to be making these records in your book. Okay, I think it's, yeah. So 1 plus x raised to the power of alpha, we use it to get other basic DLs. So in the next video I would be showing us how, because I think my battery is low and I have to, you know, change the battery. So see you in the next video. Bye.